and it would hold the shape it's in. It'd be a long rod shape, wouldn't it? It'd look like a big tube, right? But if I take it and I pour it in this beaker, now it's wider, isn't it? And it's shorter. So its shape is not the same as it was a second ago. Still holding the same volume, because I can read it up here. It's a little over 70 something. Yeah. Now, if I take it, however, and I put it in this Florence flask, a little bitty one too, right? And I pour it in there. And it should all fit, if I did my math correctly. Ooh-wee. There we go. Right to the top. Now you can see this water goes all the way to the top. Okay? But it's taking the shape of the container that it's in. It's in a glass container that's bulbous at the bottom and very neck-like tubular at the top. And if we were somehow to remove the glass, it would have this shape. Now it wouldn't hold it for long, obviously, but it takes the shape of the container that it's in. Now, that leads us to gases, right? Gases don't have either a shape that's definite or a volume that's definite. Gases take the shape of the container that's holding. You can also do one awesome thing with gases. You can compress them. You can squeeze them. You know this because you have shocks on your car, right? Or even when you were younger, when you had a bicycle. You had shock absorbers on your bicycle. Well, those were air shocks. They basically had air in them, and when you hit something, it'd do this. Well, it would be because that stuff is pressing down on that gas, and the gas would squeeze together. You can even take a balloon and squeeze a balloon, right? And it will change its shape, and you can also squeeze it tighter and tighter, right? And it can compress. That's a great thing. But again, if you look at the particles are really, really, really far apart from each other. And they're moving really fast. And they got a lot of space between each other. That's how you can squeeze them and compress them. Liquids, they're basically right on top of each other, and solids ain't moving at all. That's why you can't squeeze solids and compress them, or liquids and compress them. You can compress liquids a tad, a little bit, but not much. Okay? Now the last phase, and the most common phase, is plasma. This is gas that has been ionized. Okay? What does that mean, ionized? Well, it's turned charged. It's got a charge. Okay? So ionized gas is called plasma. It's very hot, usually. Not always, but usually. Well, it should be usually, but not super hot. Because again, I got the idea of the sun. Well, plasma's all around us. We have plasma in this room right now. You've all heard of a plasma TV, right? When they had plasma TVs, it was creating high energy, high charged gas, plasma. Okay. Right here in front of me, I'm going to do this. Turn the light off for just a second. All right. We also have this guy right here. This, as you can see, is a plasma ball. Okay? It has gas inside of it. And when I electrify it, the gas charges because of the electricity. And what you're getting is you're getting little sparks that are shooting up, and you can see these little lines, and this is plasma being formed. That's why when you take your finger on it, it allows the electricity to go through the bulb, through the gas, into your body. Now, it's not enough electricity to bother you, obviously, but when it does, it creates an even higher